Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to discuss about coded inequalities. Coded inequalities is all about comparison of two variables based on a particular parameter. Whenever we compare two variables, there are three possible conclusions. That is, let's say we are comparing the two variables A and B. So the conclusions which we can make out are A can be less than B, or A can be greater than B, or A can be equal to B. So in general, these are the three basic comparisons which can be made from two variables comparison. That is, either one of them is less than the other, or greater than the other, or both of them are equal. Now with this knowledge, let us first understand what are the various types of inequalities that we have. Now if you look at the first statement here, it says A is neither greater than nor equal to B. So when we say that A is neither greater than nor equal to B, the only possibility is A should be less than B. So we can say that A is less than B. Now if you look at the second one, it says A is neither smaller than nor equal to B. So A is neither smaller than nor equal to B. So the only left out possibility is A should be greater than B. So we can say that A here is greater than B. The third one says A is neither greater than nor smaller than B. So it is neither greater nor smaller. So the possible comparison between A and B should be A is equal to B. If you go for the next one, it says A is not greater than B. So the only information which we have is A is not greater than B. If A is not greater than B, there are two possible comparisons. Either A can be less than B or A can be equal to B. So by combining these two here, we can say that A is less than or equal to B. So A should either be less than B or it can be equal to B, but it cannot be greater than B. Similarly, in the last case, we see that A is not smaller than B. So when A is not smaller than B, we can have two possible conclusions. That is either A greater than B or A equal to B. So by combining these two now, we can say that A is greater than or equal to B. So these are the five basic type of inequalities that we have. Remember that whenever we compare two variables, the sample space will be any of these three cases. That is either A is less than B, or A greater than B, or A equals to B. So based on the given conditions, we can have a combination or any one of these three comparisons. Now, to solve questions based on coded inequalities, we need to understand the three basic rules. So let us first look at these three golden rules and then we shall take up some examples. Let us now understand the rule number one of comparison, which is based on similar inequalities. Let's look at an example here. Let us assume A is greater than B and A is greater than C. When we know that A is greater than B and A is greater than C, then we can say that B and C cannot be compared. That is, B can be greater than C, or B can be less than C, or B can be equal to C. All the three cases are possible. So whenever we have a similar inequality, as you can see here, greater than and greater than are similar inequalities, and we have the same variable on one of the sides, then the other two variables cannot be compared. That means B can be greater than C, or less than C, or equal to C. To understand this better, let us assume that A, B, C are three students and we are comparing the heights of these three students. So if you look at the first case here, it says A is taller than B and A is taller than C. So from this we can say that A is taller than B and C. But among B and C, who is taller and who is shorter cannot be established. So that is the reason we say that B and C cannot be compared. Among B and C, B can be taller than C, B can be shorter than C, or B can be equal to C. So the simple idea here is whenever we find similar inequalities and the same variable on one of the sides, the other two variables cannot be compared. The other such possible cases are this one, that is A less than B and A less than C. Here also you see that there are similar inequalities between the two comparisons and we have the same variable. Similarly, we have A less than or equal to B, A less than or equal to C, or A greater than or equal to B, A greater than or equal to C. Otherwise, we can also have a combination of less than and less than equal to, or greater than, equal to, and greater than. So in all these cases and many other similar cases, the answer should be B and C cannot be compared. So that is one of the most important rules required when we are solving questions related to coded inequalities. Let us now take the rule number 2 from coded inequalities, where we compare any two variables from the given inequation. Let us take an example. As you can see here, a number of variables have been compared and the relationship has been established as given in the inequation. The inequation here is A less than or equal to B less than C less than or equal to D less than or equal to E. Let us now understand how to compare any two variables from this given inequation. For example, the relationship between A and B is directly known to us, that is A less than or equal to B. But how to compare the variables A and C? So let us see how can we compare the two variables A and C. If you observe, the two inequalities between these two variables A and C are A less than or equal to B, B less than C. So the two inequalities are less than equal to and less than. So the relationship between A and C will be that one which is common for both the inequalities. Now if you observe, the common part in both the cases here is less than. So we can say that A is less than C. Similarly, if we try to compare A and D, the different types of inequalities which we have here are less than equal to, less than and less than equal to. Again, if we observe, the minimum common part in all these three inequalities is the less than part. So we can say that the relationship between A and D should also be A less than D. Remember, here we have three inequalities between A and D, less than equal to, less than and less than equal to. We cannot take the relationship as less than or equal to. Why? Because equal to part is not available between B and C. So we should consider only that part of the inequality which is common for all the three inequalities. Again, if we try to compare the variables A and E here, the different types of inequalities we have are A less than equal to B, less than C, less than equal to D and less than equal to E. So out of all these different inequalities, again the common part in each one of them is less than. So we can say that A is less than E. Remember, again we cannot take the relationship as A less than or equal to E, because here we don't have the equality part. So the common in all the four cases is less than. So we should take that as the relationship. So the idea here is, whenever you are comparing two distant variables which have got two or more than two inequalities between them, we should always consider only that part which is present in each of the inequalities. Let us now take another example here. Let us say we are comparing the two variables C and E. If you observe, the two inequalities between C and E are C less than or equal to D, D less than or equal to E. Now in both the inequalities we find that they are same, that is less than equal to and less than equal to. So the common part in both the cases is less than equal to itself. So now we can say that C is less than or equal to E. But once we compare B and E, we see that the relationship will be different. If you observe the variables B and E, in between we have less than equal to and less than equal to. Out of these three, the common part in all the three cases here is less than. So here we can say B is less than E. Remember, we cannot take less than or equal to as in this case, because in this case in both the inequalities we have equality sign. But if you compare B and E, we have three inequalities in which one of the inequalities doesn't have the equality sign. So the only relationship between B and E should be taken as less than, but not less than equal to. Whereas in case of C and D, we can take it as less than or equal to. So I hope the rule here is clear to all of you. The simple idea is, whenever you compare two distant variables, just see all the different inequalities present in between them and take out the minimum common part which exists in all the inequalities. Let us take another example based on the same rule. So the second example here is as shown. We can see that P is greater than or equal to Q, greater than or equal to R, greater than S, greater than T, greater than or equal to U. Again, the same rule is applicable when we are comparing two distant variables in this sort of an equation. Let us try to understand the relationship between P and S. As you can see here, the various inequalities we have are greater than equal to, greater than equal to and greater than. And the common part in each one of them which exists here is greater than. So we can say that P is greater than or equal to S. When we compare the variables R and U, Again we see that the different inequalities are greater than, and greater than or equal to. So we can say that the relationship between R and U should be greater than. Remember, we cannot take greater than or equal to as a relationship here because equality is missing in these two cases. Now, when we compare the variables R and T, we find that the two inequalities between them are greater than and greater than. So it is obvious that the relationship between R and T should be R greater than T. So this is how you can understand the relationship between two distant variables. The simple point which we need to follow is whenever we compare two distant variables, just take the minimum common part which is available in all the inequalities between them. Let us now understand the third and the last rule from coded inequalities, where we compare two variables with dissimilar inequalities present in between them. Let us take an example here. As you can see, A is less than B, less than equal to C, greater than D, greater than or equal to E. So this inequation has got dissimilar inequalities. Dissimilar inequalities are nothing but combination of less than and greater than symbols. So if we try to compare two variables such that there are dissimilar inequalities between them, then again the relationship cannot be determined. For example, let us assume we are comparing the variables A and B. As you can see here, A is less than B, B less than or equal to C, and C greater than D. So once we find two dissimilar inequalities between any two variables, we can say that the relationship between them cannot be determined. Therefore, A and D have got no definite relationship between them. A can be greater than D, or it can be less than D, or it can be equal to D. All the three cases are possible. So simply we can say that the relationship between A and D cannot be established. Similarly, if we try to compare the variables B with variable D, we find that there are dissimilar inequalities. So again here the relationship cannot be determined. And the same thing happens when we compare the variables B and E. Again in between B and E we have less than equal to, greater than and greater than equal to. So as there are dissimilar inequalities between them, those two variables cannot be compared. So the simple idea here is whenever we find dissimilar inequalities, that is a combination of less than equal to, greater than equal to, or less than with greater than equal to, or less than equal to with greater than, all these are referred as dissimilar inequalities. So whenever we have these two types of inequalities present between two variables, those two variables cannot be compared. That means the relationship between the two variables can be either less than or greater than or equal to. So that is the third and the last rule to be understood to solve questions from coded inequalities.